Here onwards, we will be discussing about minimal spanning tree model. The minimal spanning tree model deals with linking the nodes of a network directly or indirectly using the shortest total length of connecting branches. Applications of minimal spanning tree spreads in a range. Network designing, paved road constructions, phase tracking and verifications, construction of electricity grids, avoiding network cycles, sales distributions are some of them. Keep in mind that the main idea of minimal spanning tree is to find the shortest length between all nodes such that the span becomes minimum. Let's take a simple problem of finding a path which lies between two towns. Consider you have to construct a road which goes through a rural area. It is been said that there are two main villages, so the road must be planned in a way such that it lies in both of those villages. But we must not forget to reduce the cost of construction of the road. Somehow the total distance should be minimum. What would you propose as the suitable path of construction? Is it from construction point to town A, then to town B, which gives you a total of 20 kilometers, or is it the other way around, which gives you only 15 kilometers? Pretty easy, right? Road with 15 kilometers is the best. But what if the problem contained many alternatives, many houses, many connections? If you do this in your mind, you are a real genius. If you didn't, let's move. Let's start from the construction point. The minimum distance from construction point to any town is 1. Hence, construction point and town A is connected. Then we should connect the rest of the towns either to node A or to the construction point. The minimum distance lies towards town C. Similarly, town D can be connected. Now is a bit tricky. As you can probably see, we have two paths containing a minimum distance of 5. In either way, you make cycles. So those paths have to be neglected. Next best alternative is town E. Now only town B is remaining. You connect it to the nearest town. Our road system is now constructed. This is only one concept of optimization. What if you had to tackle with the traffic also? Let's switch to our next application.
Now let's move to the another concept of optimization, maximal flow algorithm. Maximal flow problems involve finding a feasible flow through a flow network that obtains the maximum possible flow rate. The objective of this maximal flow algorithm is maximize the total amount of flow from an origin to a destination. As an example, let's consider the road system of city X and it is in the process of developing a road system. The city planner would like to determine the maximum number of cars that can flow through the town from the west clock tower to the east clock tower. The numbers shown in each place indicate the maximum flow of cars in hundreds per hour, and those amounts were taken by the survey they had done in previous days. The main objective of developing this road system is reducing the city traffic while identifying the maximum number of cars that can flow through this city. As you can see here, we can illustrate this road system in this way, and we can see they have put some roads as one way. That means you cannot go only the given direction, but you cannot come backward through that road. Let's see the first iteration of maximal flow algorithm. Here we select a path from the west clock tower to the east clock tower while identifying the maximal flow of cars. Let's start from the west clock tower, and we can see that there is a maximal flow of cars from the clock tower to the bridge. Then we select that road and reach to the bridge. Again we consider which road has the maximal flow, and then we see 3 is the maximum. That is 300 cars can flow from bridge to the cafe rather than 200 cars flow from bridge to the hospital. So we choose path from the bridge to the cafe because our objective is to maximize the flow of cars through the city. Now we can select a path either directly go to the east clock tower or go to the school and then reach to the east clock tower because the flow amounts are equal. Here I select the direct path to the east clock tower and reach to the destination. Now we should note that 1000 cars are able to move from West Clock Tower to the bridge, while only 300 and 100 cars are able to move through the bridge to the cafe and cafe to the East Clock Tower respectively. Hence, the minimum 100 cars are able to flow through the selected path. So on, we can move to the next iterations with the amendments from iteration 1. We should find different paths from West Tower to East Tower until there are no any other alternative paths. We can also solve these types of problems using statistical software like Tora, Excel. When we solve our problem manually or using a statistical software, we get the maximal flow of cars from the West Clock Tower to the East Clock Tower is 5. That is, 500 cars can flow at the same time in 1 hour in the road network. And here we can identify the maximal flow of cars going through each location. When we consider the flow from the West Clock Tower to the bridge, we can see there are 4, that is 400 cars can flow. But in the initial stage we saw that 1000 cars can flow through this road. So we can say that without having traffic problem, the maximum number of cars that can flow through the West Clock Tower to the bridge is 400. Further necessary steps can be taken to reduce the traffic, such as widening the bridge, road, etc. Not only the road system problems, we can also see maximal flow problem is a special case of a more complex network flow problem. Let's consider a few examples. We can use this algorithm to determine the maximal flow amount of water, oil or gas through a network from the source to the sink, and also maximize the flow of railroad system that shifts the product from one town to the other town. Furthermore, we can use this algorithm for baseball elimination, airline scheduling, circulation demand problems, image segmentation, and oil distribution system.
Now, we are going to discuss about how optimization is used in assignment problem. The assignment problem is a special type of transportation problem where the objective is to minimize the cost of allocating a number of jobs to a number of people or facilities so that one person or facility is assigned to only one job. For example, imagine that a company needs to complete 4 simultaneous research. The company is going to hire 4 scientists to complete them. Note that a scientist will be assigned to only one research. The grants requested by 4 scientists for 4 researchers varies. As there is limited amount of grants, company decides to assign job with a minimal cost using Hungarian method. Similarly, we can see assignment problem in various real-life situations such as assignment of machines to jobs, assignment of salesmen to sale territories, traveling salesman's problem, timetable problem, allocation problem. Let's move to the next application of optimization, finding the shortest path. Here we are going to discuss about 2 algorithms, Dijistra's algorithm and Floyd's algorithm, and the differences between those 2 algorithms. Dijistra's algorithm is an algorithm for finding the shortest path from the source node to specific destination. The algorithm is widely used in automation. The drones, robots, which are automated and are used to deliver the packages to a specific location and loaded with the algorithm, so it moves in the ordered direction following the shortest path. But unlike in Dijistra's algorithm, in Floyd's algorithm, we are able to find out the shortest distance between any pair of nodes. It works in either directed or indirected graphs. So this makes a robot drone to deliver goods between nodes considering the shortest distance in a pair. So Floyd's method is more general than Dijistra's. Finally, we are going to discuss how optimization is used to minimize the cost of transportation. Transportation algorithm is a mathematical model which represents linear relationships, like transportation between a supplier and a destination. Hence, The main goal of transportation algorithm is to determine the optimal solution. Simply, we are trying to transport our products for the least amount of money so we get the most profit. Now consider the following example. Imagine that a network of companies located in Canada, China, Australia wish to transport COVID-19 vaccine to Brazil, England and Russia. The company needs to find the minimal transportation cost according to the supply and the demand. Note that the cost of transportation of vaccine differs from one to other. We can model this problem into a transportation model. After that, we can find the optimal schedule which minimizes the transportation cost using a computer software. Now, the company can distribute their COVID-19 vaccine at a low transportation cost and they can fulfill the demand of each country. Hope you are satisfied with the knowledge gained through the series of presentations. Feel free to ask any questions and thank you for your participation.